it was brought to my attention that apparently I start every video by saying, all right, before I introduce the lesson. So this time I'm going to try not to do that. This lesson is on functions, and more specifically, we're going to talk about function tables. But go ahead and get your notes set up, get your title, your learning target and its description, and then our all-important I can statement. What's the point or what's the goal of our lesson? All right, for this page, you don't need to write anything down. I just want you to kind of follow along as a quick little introduction to what a function really is. Okay, sometimes you might have learned it as an in and out machine. It's basically we plug something in, we plug a value in, we do something to it, and out pops a result. So think of it kind of like a recipe. We add together a whole bunch of ingredients, we do something with it, and out pops a cake or muffins or cupcakes or something like that. So let's take a look. So I'm going to take a 5. And I'm going to drop it into my function, and out pops a 2. So a 5 goes in, out pops a 2. Now let's try a 7. A 7 goes in, out pops a 4. So 7 input, 4 for an output. So think about how did a 5 turn into a 2 and a 7 turns into a 4. Okay, you might already have an idea of what the rule is, but let's try one more. So this time let's put an 8. What do you think is going to pop out on the other side of an 8? Well, let's see if you're right. Put in an 8 and out pops a 5. So what was our function? What was our rule? What did I do to my input to get my output? Hopefully you realize that each time we were subtracting 3. I'm supposed to say that under my hat, but I accidentally locked it in place so I can't move it away. But our function or our rule was we're going to subtract 3 from whatever our input is. So that's what a function is. We input some numbers, we apply a rule to it. Maybe it's adding, maybe it's multiplying, maybe it's dividing, maybe it's 2 things, and out comes our output, our result. So let's get some vocabulary into our notes. So a function is a relation that assigns exactly one output value to one input value. So for everything I put in, I get exactly one thing back out. We don't want something where if I put in a 2, sometimes I get a 3, sometimes I get a 5. We just want to know that if I plug in a 2, I'm always going to get the same thing back out again. And then we have our inputs and our outputs. Our inputs are the values you plug into the function. They're what you put in. We call those our x values. Our output is what we get out of the function. It's kind of our results. We call those our y values. So we plug in the x's, we do something to them, out pops the y's that go with it. So let's put this together a little bit. Go ahead and jot these couple down in your notes, and let's work through them together. These are our function tables. We take our inputs, we apply a rule to it, and we get our outputs for our answer. So in our tables, we're going to show our work of what did we do to our number. So it says for every x, we're going to add 7. So let's put in 10. So I get 10 plus 7. 10 plus 7 is 17. So the middle column is how did we apply the rule or how did we apply the function to it, and then what did we get out? So here we plug in a 12. 12 plus 7. 12 plus 7 is 19. And then I plug in my 14. 14 plus 7, well 14 plus 7 is 21. So that's how we apply our function. We take our inputs, we use a rule, and we get our outputs or we get our results. So let's try this one. So this time our rule is 5x, 5 times x. So we're going to plug in each of our inputs in place of x and see what we get. So first I do 5 times 8. 5 times 8 is 40. Then I plug in a 10 for x. So now it's 5 times 10. That's 50. Then 5 times 12. So we're just plugging in each one of them and getting our answer. In this case, I'm going to get 60. It's as simple as applying the rule to our inputs, basically just doing a quick little problem, and then out pops our outputs. So I want you to copy down these 2 tables in your notes. Go ahead, try them on your own, show the work in the middle, then get your results, And then at the very end of the video, I'll have the answers for you, and you can see how you did. All right, now a little bit more challenging. Now we want to work backwards. We know what our rule is, 2 times x, but I want to know how the heck did I get this output to go with it? So I want to work backwards. So I want to know, what would I multiply times 2 to get 1 as an answer? Well, to get from 2 to 1, I would actually have to get smaller. I would only want part of it. So what I really multiplied by is 1/2. So I get an answer. My input was 1/2. Here, I put in a 3, or I got a 3 for an answer. So I want to know, what would I multiply times 2 to get 3? Well, to get from 2 to 3, I would have to multiply times 1.5, or if you think of it as a decimal, it would be 1.5. 1.5 times 2 gives me 3. So here I have 1.5, or you could think of it as 1 1/2 if you wanted to, if you want to leave it as a fraction. And then our output, we want to get 5 for an output. So our rule is 2 times something, so 2 times what gives me 5? Well, if I think backwards, or if I go in reverse, 5 divided by 2, I would get 2.5 as my answer. So I must have plugged in 2.5 in order to get my result. So basically you're thinking the problem backwards. Okay, they multiplied something times 2 to get my number. So I need to go backwards and figure out what did they start with. So let's try this next one. This one's a little tougher because it's a 2-part process. They multiplied times 3, then they added an extra 2. So we got to work backwards. So think about 17. We did 3 times something, then we added 2 to get to 17. Well, I like to kind of work backwards, a step at a time. So they added 2 and got 17. Well, the only thing I can think of that I would add 2 and get 17 is if I had 15. So that means 3 times something had to give me 15, because then I added 2 and got 17. Well, 3 times 5 gives me 15, plus 2 is 17. So my input must have been 5. So let's do the same. 3 times what? Plus 2 gives me 29, or 20. Well, think hard about it. Our last step was to add 2, and it got us to 20. So what plus 2 gives us 20? Well, that would be 18. So 3 times what gives me that 18? Well, 3 times 6 gives me 18, plus the extra 2 got me to 20. So my input must have been 6. So I want you to try this one. Think about 3 times what, and then I add an extra 2 would give me 29. Your job is to try to figure that one out and finish filling in that table. All right, our last 2 examples, you're going to do these in your textbook. So pause right now and open up to page 582 in your textbook, and then work through these 2 problems. They're about halfway down the page in the guided practice area. Okay, so here's our first one. It says Isaiah is buying jelly beans. In bulk, they cost $3 per pound, and a candy dish costs $2. So our function rule is 3 times x plus 2, where x is the number of pounds, can be used to find the total cost of x pounds of jelly beans and a dish. So basically we want to know, if I buy 3 pounds, or if I pay $3 per pound plus I buy an extra candy dish, what's it going to cost me? Well, they want us to try it for 2 pounds, 3 pounds, and 4 pounds. So those are our inputs. Those are our x's. So I put my 2, my 3, and my 4. Then I go ahead and I do my function rule. I apply the rule. So 3x means 3 times whatever x is, plus the extra 2. Yes, you need to write out that part so we can see how you're applying it. And then our output is our overall cost. So that's going to be our y. 3 times 2 is 6, plus 2 is 8. Then we put in 3 pounds. So 3 times the number of pounds, plus $2 for the dish. 3 times 3 is 9, plus 2 is $11. And the last one you should be able to do on your own. Plug in 4 in place of x. 3 times 4 is 12, plus 2 is $14. So we've been able to use our rule to calculate what would be the cost for 2 pounds, 3 pounds, and 4 pounds of jelly beans in this case. So go down to the next problem. This one we're actually going to go ahead and graph our results and use them. It says Jasper hikes 4 miles per hour. So every hour he hikes an extra 4 miles. The function rule that represents this is 4x. So 4 times x, 4 times the number of hours. We want to make a table to find out how far or how many hours he's hiked if he's gone 8, 12, and 20 miles. Now be very careful with this one. Notice they're giving us the miles. Miles is our output. So our 8, 12, and 20 go in this column here. So this is one of those where we're going to be working backwards to find what we put in. So now we work backwards. So think about 4 times what gave me 8? Well, 4 times 2 gives me 8. So 2 must have been my input, my number of hours. Do the same thing for 12. It was 4 times what got me 12? Well, 4 times 3. So my number of hours is 3 hours. And last one, 4 times what gets me 20? Well, 4 times 5 gets me 20. So my input was 5. Okay? So the key in this one is they didn't give me my inputs. They gave me the outputs, and I had to work backwards to find the input. But now we're going to go ahead and graph it. Remember to graph a point. It's always x and then y. So here I had 2 for x, 8 for y. So I had the point 2, 8. So I'm going to go over to 2 hours, and then I'm going to estimate my 8 miles there. Next one I put in 3 and got 12. So that's the point 3, 12. So I go over to 3, up to 12. I'm noticing my lines are just a little bit off with my numbering down here at the bottom. So hopefully yours are lined up correctly for you. And then my last one is 5 and 20. So that's the point 5, 20. Remember the x, your input is always first, and then your output. Here's my 5 and 20. So you can kind of notice how it's going on a nice continuous line, increasing at the same rate each time we go along. So that's how we use our function tables in order to create some points that we can graph. So we're all finished with the lesson. Here are what your answers should look like for those 2 problems partway through the lesson that I asked you to do on your own. All right, hopefully now you've got a good understanding of what we're looking for a function table and how to tackle one of the problems on your own.